Good morning.
Good morning.
Good morning.
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 All right, I'm all set. Sorry, I'm late, couple of minutes. My previous class students held me up. Okay, so let's see. I'm going to share the screen. And the review sheet is on the left of the screen. You can ask questions from the review or last homework or any homework, actually. I will take any question. In fact, my previous class asked me questions on homework, going back to homework 8, homework 9, everywhere. So you can do that too. This is the latest assignment. We can begin there if you have questions on that.
Yeah, that would be good. That was confusing for me.
Okay. This one.
Professor, can we go over 2B?
2B.
Yes.
This one.
Yes.
Okay. That says float n and s equal to 0, n equal to 0, and going from 1.
Wait, 2B was homework? I thought it was 2D and 2E.
2B was on 14.
2B was
For Monday.
Previous one.
Homework 13, I think.
Yeah, it was with the 14, I believe. Homework 14. I can still go over that. You wanted that, right? All right, somebody wanted it, so let me go over that. N starts at 1. S less than loop will go until s less than equal to 50 is false, and n equal to n times 3. Okay, so let's trace. You basically you're supposed to trace the loop, making.
Wait, Professor, you only wrote 2, and then you wrote D and E in parentheses. I thought that was the only questions that you had to do.
It's for Monday.
Oh, this is number 4, homework 14.
Previous homework. This was previous one. Okay. 2B was part of the previous homework, not the latest.
Oh, okay, gotcha. My bad.
So N, S, and M are changing. So N, I'm writing 3 columns for all of them. I have 3 columns, S, N, S, and M, N, S, M. All 3 are changing in this loop. So this is how you trace it. N is initially 1, S is 0, and M is 0 initially. Then loops are, now the S less than equal to 50 is true, so therefore the loop will start and it will add N to S. So S becomes 1 now, and then N changes by 1. And that's all you're doing in the loop. And then N is changing N is multiplied by 3. That the N equal to N times 3, this statement is always at the bottom of the loop. It'll be executed as if it's at the bottom of the loop. So N will be multiplied by 3, and you have that. Now S less than 50 is true, so therefore S will get N added to it. So S will be 4, and M changes to 2, and then N will be multiplied by 3, and you have that. The condition is checked again. S less than 50 is true, so it'll go on to do it again. So S will get N added, 13, and M changes. M is basically a counter, and the N changes to 27. Still under 50 is true, so therefore it will add 27 to 13, 40. And counter changes to 4, and S less than 50 is still true, so therefore N will be added to S, 121, and M changes to 5, and N changes to 243, and then now the S is bigger than 50, so loop ends, and when the loop ends, your cout statement will print on the screen. So if this is my screen, I'll write S121, and on the next line, I'll write 5. Okay. Anything else?
Oh, 4A.
4A. Okay, so 4A has a pattern. The first statement is 1, so we can start our sum at 1. We don't have to worry about generating first term. Second term, 1/3 squared, and then 1/6 squared, 1/9 squared. If you look at those, the number in the denominator is going up by 3. So that's the pattern we need to use. So therefore, I will declare my variable float sum equal to 0. No, not 0, 1. That way I can hold that first element added to the sum. The first term of the series is added to the sum already. So sum will be 1. And I'll declare my N as a float 1 also, because I am going to be dividing 1 by it. So I'll declare that as float N equal to 3. So N is the number in the denominator. It's 3 initially, it'll change to 6 and 9 and so on. While N is we can use a for loop. Actually, there's a clear pattern, but I'll use while loop. While N is less than or equal to 729, sum plus equal to, sum equal to sum plus 1 over N times N, 1 over N squared. That'll add 1 over 3 squared. And right after that, N should change to go to the next one. And as you can see, it's going up by 3. So I need curly bracket now because I'm writing 2 statements in the loop. N equal to N plus 3 and close. So initially N is 3. So 1 over 3 squared is added to sum, and then N changes to 6. And with that, you go up. If N is still less than 729, then you're adding 1 over N squared. So 1 over 6 squared is added, and then N changes to 9. 1 over 9 squared is added, and so on. Eventually, when N becomes 729, 1 over 729 squared is added to the sum, and then N changes to 732, and that's when the loop terminates. So when the loop terminates, sum is ready, so cout sum. All right, anything else?
I have a question. Do you know what the exact value of the sum would be? Because I wasn't sure if I even did it right when I did it.
No, I don't know the value of the sum there.
Yeah.
I didn't execute that program.
Can you go over 4B?
Okay. So this is 4A. I'm doing 4B. So it's the pattern, the 1 times, 2 times 3, and then 2 times 3 times 4, 3 times 4 times 5. I'm going to look at the first number. The very first number in the product is 1, and in the next term it's 2, in the next term it's 3. So I can make a for loop with int n declared up here. The for n going from 1 to n less than or equal to 39 n plus plus. See, n is very first number. If you look at that, that's going from 1 to 39. I need a sum variable to hold the sum and set it to 0 initially. Inside the loop, all I need to do is sum plus equal to n. The n is holding the very first number of the term, multiplied by n plus 1 times n plus 2. That'll get the entire term calculated and added to sum. That's all I need to do. In the loop ends, see out the sum. Let me show you how it works. When n is 1, initially n is 1, 1 times 2 times 3 is added to sum and stored it back in sum. Then n becomes 2. Now 2 times 3 times 4 is added to sum and stored it back in sum. And then n becomes 3. 3 times 4 times 5 is added. Eventually n will become 39. 39 times 40 times 41 is added to sum. And n becomes 40, and that when the loop terminates, because this condition is not true anymore. So last statement executed is going to be 39. The last term added will be 39 times 40 times 41. All right, anything else?
Professor, can
Yeah.
I show you what I did? Because I did it a different way.
Did you use 3 variables?
Yeah.
That'll be correct too. I mean, there are
Okay.
different ways.
All
There
right.
are many ways to do that.
All
And you can use 3 variable A, B, C and increment each one to get the next term. Yes, that's fine.
Okay, that's what I did.
Yeah, I did the same thing as well.
Yeah, absolutely. There are multiple
I-
ways to do the same thing.
Yeah, I did that too. I sent the thing in the chat. I
In the chat.
yeah, to see if that's correct.
ABC and add ABC and increment right after that. Yes, absolutely.
Thank you, perfect. Thank you.
Yeah, you could have controlled by, you're controlling by C. That's correct. You can control by A, B, or C, either one. Yes, that is correct, question.
Professor, what happens if you control it by all 3?
Why would you do that? I mean, there's no reason to do that, right? It's not wrong. I mean, if you write in the while loop, the condition Ismail has C less than or equal to 41. So you are saying you wrote A less than or equal to 39 and B less than or equal to 30.
Correct.
40 and C less than or equal to 41. Okay. Kind of odd, unnecessary work for the system to compare all of those each time. That's each time, right? Not just once. So it's not the efficient program, but it's correct if you compare all 3 of them. But that's really unnecessary, right? Okay, anything else? You don't have to
Professor,
do
did we go over 2D?
2D in the homework.
Correct.
Yeah, all right. Okay. (2D) is to write the output of this. Okay, so let's begin with the outer loop, first loop, for in k equal to 5. That loop begins with k equal to 5. And with that, you enter the second loop where m begins at 1 and goes up to k. K is 5 right now, right? So when m is 1, m less than k is true, so C out S will be executed. So on the screen, you have a $sign printed. And so this loop just started with m equal to 1, and it's going to go all the way until m less than k is not true. So right now, 1 less than k is true. So you see out at yes, and m goes up by 1. So m is 2 now. 2 less than k is true. 2 less than 5 is true. So C out S will be executed again, which will print another $sign. M becomes 3, and C out S is executed. M becomes 4. 4 is still less than 5, so another $sign. And now M becomes 5, and the loop terminates. So inner loop terminates. When inner loop terminates, the C out E and DL will be executed. That'll make the cursor go to next line. Now on the screen, cursor is on the next line. With that, you hit the bottom bracket, and that's when you are going to the back to the outer loop and changing K by 1. K becomes 4. With K equal to 4, you enter the inner loop again. And inner loop begins with M equal to 1 and goes up to 3 because K is 4. So inner loop begins with 1, and it will write $sign. M becomes 2, another $sign. M becomes 3, another $sign. M becomes 4, loop ends. And now C at E and DL will be executed. Cursor goes to next line. Now K is decreased to 3, and then you enter the inner loop again. M begins at 1 and goes up to 2 and writes $sign. When M becomes 3, loop terminates, and E and DL will be executed. Going to next line. Now K becomes, it was 3, now it's 2. When K is 2, you go into the inner loop again, M equal to 1, and you write $sign. M becomes 2, loop terminates, and cursor goes to next line. And now K becomes 1, and you go into the inner loop. M is 1, and 1 less than 1 is false, so inner loop doesn't execute, but E and DL will execute. But the outer loop now terminates. So your output is what exactly I have on the screen now. This is your output. 3 lines of $signs. Anything else? We don't have to do the homework. If you're finished with that, we can go on to the review. Or any other homework, previous homework, question from anywhere.
In your review, I noticed in a couple different answers, number 8 and number 14, in the group, you kept dividing like numbers by 2 in the middle.
I'm having a hard time hearing you. Maybe, yeah.
Hold on. Can you hear?
Are you on the review or another homework? I think we lost her.
Professor, can you go over, give me a second, 4.4, number 4? On the, it was homework, I think 13.
Homework 13.
Yes, it was 4.4, problem 4.
Okay.
You said that for my homework, you said loop never starts. I don't, I understand that. I kept looking.
Yeah, sure. Homework number 13, you said, right?
Yes.
13. All right. 4.4, number 4.
Yes, yes, yes.
Yes. All right. Let's clear the screen.
Professor, how many questions are going to be on this test?
About 40.
40?
Yeah, it'll be slightly smaller than last one. Last one had 50 questions. This will be smaller because I don't have those theoretical questions anymore. No filling the blank and stuff. No theory questions.
So it's just going to be questions like, what does this code like print out? And then like writing out code for specific questions, basically.
Yeah, a whole bunch of problems will be small programs and you write the output of, right? That they were there in the first test also. A bunch of little programs, you write output for it. And when you write output, you have to write exact output that you expect to see on the screen. If two numbers are going to be one below the other, they must be written one below the other. So that kind of questions will be there, a bunch of them. And then another bunch will be just asking you to write statements to achieve the indicated task. So there'll be just 1 or 2 or 3 statements, sometimes 4 lines code you have to write. And then there'll be programming questions, about 4 of them. All right, so studying all the homework will be helpful, homework and projects. Making sure you know how to do them will be helpful. All right, I'm going over the number 4. Write this program to determine number that is power of 7 as well as nearest to 100, nearest to 2000 and under 2000. So you have to be closest to 2000 and under 2000. And it has to be a power of 7. Okay, so you start your number n at 7 then, int n equal to 7. And then if you multiply this by another 7, you'll get 7 squared. Multiply by another 7, you get 7 cubed. So you can generate all the powers of 7 using this one number. And we need to generate all those powers and see which one is under 2000. But we have to keep multiplying until it goes over 2000. So therefore, while n is under 2000, I will keep multiplying n by another 7 to generate the next power of 7. So n equal to n times 7. I have to keep doing it as long as it's under 2000. Now, what you did was, Ismail, what you did was you said n greater than 2000. Just because we need to find the number that is under 2000, you thought while it is over 2000, we have to keep going. But if you write the condition as n greater than 2000, can you see that the condition is false to begin with? N is 7 right now, and it is not over 2000.
Yeah, I looking back at it, I see. Yeah, it's probably a mistake, but it doesn't matter. Yeah.
Not write that, that will not start. That with that loop will never start. So you had to find the answer in some other way. So we still have to write n less than 2000. So this will generate all the numbers. So 7 to the power 1 is where we started. It'll go to 7 to the 2, 7 to the 3. So let's say 7 to the power 5, 7 to the 6 is over 2000. I don't know which number it is, but let's say 7 to the 6 is over 2000. So when the 7 to the 6 is hit, it'll be over 2000, so the loop terminates. And when the loop terminates, we need to see out the answer, but we know that 7 to the 6 is over 2000, so the previous one is what we need. That was under 2000 and largest. That was the largest number under 2000, right? So we just have to print the previous number. To get to the previous number, divide the current value by 7. That'll be the previous one. Okay. All right, you understand now, Ismail?
Yeah, Professor, thank you.
Okay. Anything else?
Can we go over question 5 in the review?
Okay, question 5.
Also, Professor, I think Alexandra, when she was trying to speak before, you couldn't hear her, so she also put her question in the chat.
Okay, Probably she's having some problem with the sound system. Because I was having trouble hearing her, and then after that, I didn't hear it at all. So I will get to that question from Alexandra right after going over this question. This student wanted, I'm sorry, did you say number 5?
Yes.
Yes. So let's do that, and then I'll take Alexandra's question. Write a for loop. Now, by the way, in the test, I will not ask you to write a for loop. Okay, I'll just ask you to do the problem no matter whatever way you like to do it. In other words, you're free to use for loop or while loop, no restrictions. So this one says write a for loop to print all the odd numbers between 1 and 50 inclusive on one line with space in between. Okay, so you're just writing all the odd integers. So it'll be 4. Let's declare int n, and then 4 n going from 1 to n less than or equal to 50. 50 is not odd, so it'll be 49. N plus plus. For all those n's, we want to just see out the n. Now n equal to n plus plus is wrong because we are writing the odd numbers. Yeah, odd numbers only. So n plus plus has to change to n equal to n plus 2, because to get all the odd numbers, you have to begin at 1 and increment by 2, n equal to n plus 2. See out n, and then you need a blank in between, and no ENDR. So after each number, you want to put a blank and then write the next number. So this will write all the odd numbers from 1 to 49 with blank in between. All right, let me go to now a question on the chat. Type my question in the review for number 8 and 14. In the loop, you put num over 2 in both cases, and I don't understand why you're dividing by 2 in those questions. Okay, 8 and 14. Going over to 8, obtain positive integer from the user and determine whether or not it's a prime number and write that conclusion on the screen. Okay, I understand your question. My test numbers for divisor goes from 2. 2 is the lowest test divisor, test number for divisor. And the largest test number for divisor would be num over 2. And yeah, I mean, in the past, we used num minus 1 as the number, the highest number you need to test. But let me explain why num over 2 is the better one. See, num, let's look at a number like, let's say 34. The largest divisor of 34 would be 17. Nothing more than 17 can divide it, because when 17 divides 34, you're getting a 2. Any larger number dividing 34 will have to be smaller than 2. Then that means they cannot divide. Now you can imagine any number, for any number, the largest number that can divide it evenly is half of that number. There is no divisor bigger than that. So that's why to find all the divisors of any number, 34 is a bad number, but let's say 58, you want to find all the divisors, you start at 2 and test 3, you test 2, 3, 4, all the way to half of that number, 29. And no number bigger than 29 can divide 58. That's why it is more efficient to go only up to half of that number and not all the way to 1 less than the number. none of them after 29 will divide 58. All right, I hope you explain. I hope you understand that. That applies to both 8 and 14. In both problems, you're finding devices. So when you're testing for devices, you only need to go up to half of that number. The test number will go from 2 to half of the number.
Can you hear me now?
Yes, so now I can hear you. That's good.
So if we put 58, let's say instead of 29 on the test, would it be wrong technically, or just more efficient to have 29?
Okay, if you write 57, 58, you should not. 58 is not supposed to be a device, right? If you go up to 57, that's not wrong. It's just a less efficient program. So I wouldn't mark it wrong.
Okay, thank you.
Mhm. So, I mean, now I have explained it. Now you can see that if you're testing for devicer, you can go up to half of the number. The test number can go up to half of the number to make the program efficient. All right, anything else? Anybody?
I have a clarifying question for the first one on the review sheet where it says x equals 5, y equals 3, and z equals -2. Those are all true or false questions, right?
Yes.
Okay.
Yes, these expressions, the logical expressions, will evaluate to be true or false. They're not going to be 1 or 0. I know they are in the answer I have 1 or 0. That's my error, really. I shouldn't have written 1 or 0 because these logical expressions will produce true or false. Only if you convert them to integer, they will be 1 or 0. Okay, so
Okay.
you need to write true or false. So ignore my answers. Sorry about that. I haven't. I have minor things, minor errors like that. I haven't fixed yet. They should be true or false. All right. Anything else?
Can you go over number 6?
6. Okay. Write a program that prints price and tax in 2-column headings, and then prints these numbers in the first column and the sales tax amount 6% in the second column. All right. Okay, now we know the how the numbers are going to go. It's going to go from 5 to 100 with the increment of 5. So we can use for loop to control those numbers. So the first, I declare the variable int n, and then see out the titles, price, \t, tax, ENDL. And then for n going from 5 to n less than or equal to 100, it has to go up to 100 and increment by 5. For all those n's, I need to see out n, the same number n, and then in the second column, I need to put the 6% of n. So I need to tab over and then 0.06 times n, and then ENDL. ENDL at the end, and semicolon there, and that's all on that line, and that's it. That'll print each number n, and then the tax on the second column for all the numbers from 5 to 100. So it'll prepare a 2-column report.
Thank you.
Mm-hmm.
Professor, can you go over 18?
Okay, 18. From the review. 18. Write a program that determines how many terms of the series, of the infinite series, should be added up to get the number that is just over 1,000. All right, so the numbers are 1 squared, 5 squared, 9 squared. So they're going up by 4 and starting at 1. So let me start my sum at, they're all integers. So int n and n equal to 1, and then sum equal to 0. And then I need to add n squared, each number squared to the sum, and then increment the n. N is 1, and I add the 1 squared to the sum, and after that, n should increase to 5, and so on. So we need to repeat the adding and changing n. So therefore, I need while loop. While, we'll come back to the loop control later. I need to say sum equal to sum plus, that's same as sum plus equal to n squared, n times n. After that, n should change to the next one. So always use this pattern. Don't change the n first. Always start the n before the loop, and then use that n, then change the n equal to n plus 4. If you follow that pattern, you cannot make a mistake. With the new n, we go back to the top of the loop and check the condition. As long as condition is true, we will continue to add another n squared. So what's the loop control? Anybody?
I put sum is less than or equal to 1,000.
Right, sum less than or equal to 1,000. So as long as sum is less than or equal to 1,000, keep adding n squared to the sum. And so that's what it'll do. And eventually the sum will be over 1,000. That's when we stop. And we need to get the count. How many times? Yeah, I didn't realize that. So I need to introduce count, set it to 0. Remember, count and sum should start at some value. Otherwise, this won't work. Because here you're saying sum equal to sum plus. That means there must be a value in sum to be able to add to it. So the counter should increase as well. And so when the loop ends, count has the answer.
Could you do n plus equals 4 for that second line too?
Yeah, of course. Yeah, this can be written as
Okay.
n plus equal to 4. Yeah. All right, anything else?
Can we do number 7?
All right. 7, write a program that reads the floating point number from keyboard and determines to what power number should be raised to get the value that is just over 300. So it is very similar to the one I did earlier with the 7. I did with the 7. Now this time you're going to have to do it for any number that the user enters. That's the only difference, but I'll write it anyway. Clear screen. So I need to work with a number, I'll call it n, and the n can be floating point number. So float n. And ask the user to it says determine what power the number should be raised. That means I need a variable power to keep track of the power. So introduce the power here. I'll initialize it later. Cout, enter number, and then the number is going to be stored in variable num. Let me introduce num as a variable to hold that. Num. And so now we need to figure out that number raised to what power will be just over, so I don't need the n. Num raised to what power will be just over 300. Okay, so n will be, so I'm raising num to certain power. So that means don't use the num itself. The value in num we need to keep. So we don't want to erase that. So let's say user entered like 3.5. Then that 3.5 I had to keep there. And I have to generate 3.5 squared, 3.5 cubed, and all those I have to generate. So therefore, I'm going to use this other variable n to generate all those powers. I don't want to generate those powers and put that in here because I need the 3.5 saved somewhere. So I will keep the num holding the 3.5, whatever user entered. So I'll start my n at whatever user entered, which is num. And then while n is where all the powers of 3.5 will be stored. Right now, n equal to 3.5 itself. So the powers should be right now 1. I can go back and store 1 in power. So right now I have n holding num to the power 1, and so therefore power is holding the power 1. While num n is less than or equal to 300, we have to keep generating these powers as long as it's under 300. So while n is less than or equal to 300, multiply n by another num, n equal to n times num, to generate the next power up and increment power. All right, you see what's going on, right? Num is 3.5, let's say 3.5, and num holding 3.5. N is taking a copy of 3.5. And while n is under 300, multiply n by another num. So now I have 3.5 squared, and power changes to 2. Both of these have to be in the loop. And with that, I go to the top, and now I'm comparing 3.5 squared to 300. And it is not, it is still under 300. So therefore, I multiply the n, which is 3.5 squared, by another 3.5. So now I have 3.5 cubed. And power goes up to 3. And testing the n against 300. So this will keep going as long as it's under 300. And when it eventually it will go over 300 and it will stop. At that point, the power has the power. So C out power. Power has the power we need.
Thank you.
Any other question?
Can we just go over the general structure of the test, like how many questions it'll be and how long we have?
Okay, I will give you half an hour extra time like last time. So if you have the time after the class, our class begins at 9:25. I had to begin at that time. Actually, if you prefer to start earlier than that and have extra time, I can allow that. So my morning class begins at 7:30. So if you prefer to take the exam with them, you can do that. But if you decide to take it with them, I'll have to set up a password so that others who are not in the meeting will not be taking the test. So that's the only thing. You'll have to enter a password. So if you're in the meeting, I'll give you the password. So you can do that if you want to start at 7:30. If you want to start later, you can do that. Then you still need password. But no matter when you start, the time limit applies. The test will automatically stop after giving you the allowed time. So you have to finish it in that time. Time is 1 hour and 45 minutes total that you can have. Test is designed to be 1 hour and 15 minutes long, but I'm giving you half an hour extra. So 1 hour and 45 minutes. So it will automatically terminate at the time when the time is up. So basically you can start early and have the extra time. If you have a class after our class, then you may want to do that. If you don't have class after our class, then I can go half an hour after the ending time. So you can have extra time by variety of different ways. You can start at 7:30, or you can start at 9 instead of 9:25. No matter how you want to do it, you'll get the same amount of time. Okay, the test will have problems such as writing output for little programs like you did in the last exam. You had to write the exact output. If there is going to be a decimal point behind the number, then you have to have the decimal point behind the number. If there will be two numbers, one below the other, then you have to show two numbers, one below the other. So exact output will be expected for those questions. And then there will be another bunch of questions that will say, write statements to achieve task. So some will be if statements, or such a question such as write X and Y already have X and Y have integer numbers already, and write a program to write them in increasing order, let's say. Then it'll be an if statement, right? If X greater than Y, then see out Y first, and then ENDL X, increasing order. So smaller one has to go first. Y. Else, see out X first and then Y, right? Just to give you an example. So to test to see whether you can apply a if statement to achieve a task, you can apply a simple loop to achieve a task, things like that. So these questions will involve like 2 lines to 5 line codes. You have to write to answer those. So there'll be a bunch of them. And then there will be programming questions, probably 3 or 4. I haven't fully made the test yet, partially made it, but I haven't finished it yet. So about 4 programming problems may be there. For the programming problems, you have to write the whole program, starting with main. Anything else about that?
Professor, this is closed notebook.
I'm sorry?
This is closed notebook.
Yes. No book. But even if I allow book, the book is not going to be helpful. You'll be wasting time turning pages. Yeah, technically it's no book, no notes, nothing in front of you. And when you're taking the test, you're not supposed to be using any other software. Absolutely nothing should be used. Only this program should be, only the Blackboard should be used, nothing else. Even the calculator found in the computer, you're not supposed to use. You're supposed to use a calculator, physical calculator, and you need to have one. Not for, I mean, it's not going to be used as much as it was used in the first test, because in the first test you had to calculate like exponents, right? 2 to the power 27, things like that. You're not computing anything like that, but simple calculations you may have to do, like calculating, 15% of something, things like that. So I advise you to have a calculator available, scientific calculator, in case you had to find the exponents. It has to be a physical calculator. So nothing, no software on the computer can be used. And anybody who violates that rule will fail the test. And I wouldn't be looking at your screen, so I wouldn't know, but I have other ways to know from the test whether anything else was used. Stick to that rule, then you'll be fine. Last year, I mentioned to you that 7 students were failed because they violated that rule. They were passing information to each other. And I was able to figure out by looking at the test. And they were all failed. Okay. And also they were reported to the vice president, and there is that inquiry still going on. Yeah, anyway, we'll move on. Any other question?
Can you go over 15?
Okay. 15 says, write a program that obtains 3 integers from the user and prints the smallest integer between 2 and 20 that divides all of them. So you're finding a divisor of all 3 numbers. Okay, so let's do that. The number you find should divide all 3 of them, and it has to be between 2 and 20. All right, so let's declare those variables. Declare variables for all the 3 numbers, and that's int a, b, c. And then the test number for divisor will be test. And I'm leaving that without a semicolon in case I had to come back and add more variables. So let's ask for the numbers, C out, enter 3 integers, C in, A, B, C. And then our test number is supposed to go from 2 to 20, and there should be any number in the range 2 to 20, and it has to divide all of them evenly. Okay, so our test number will go from 2 to 20. I can use a for loop, but I'm going to use while loop instead. So I'm going to start my test at 2, and while to test all of those numbers, I have to use while loop. While test is less than or equal to 20. I have to go all the way up to 20. And then my testing has to be an if statement. If my pen has been working fine so far, and now it's kind of getting tired, I guess. Let's try again. Test less than or equal to 20. I need to test every number. I need to test this number to see if it divides all 3 numbers. So I had to see if A modulus test equal to 0 and B modulus test equal to 0 and C modulus test equal to 0. All 3 have to be true. If all 3 are true, then I'm going to write that number as answer. Also, if all 3 are true, then I found the smallest device. According to the problem, we only need to find the smallest device. We don't need to find all of them. That means I don't want to go through the loop once I find it, right? So I need to start the loop once I find it. So therefore, I'm going to make a small modification to my program, go back to and eliminate the parentheses, because I want to introduce a flag variable so that I start the loop when the common divisor is found. So I go back to the declaration of int variables and set up a flag called found and set it equal to 0. flag is 0 as long as I haven't found the common divisor. When I have found the common divisor, found will be set to 1. So if this is true, if this if statement is true, then I need to say cout common divisor equal to the test. The test number is my answer. If that happens, I also need to set my found to 1. And since I have 2 statements in the if, I need brackets. Okay, so if this test number divides all 3 of them, then I'm writing the output, and then found is set to 1. And when the found is set to 1, the loop should not continue. So the loop condition, in addition to the test less than or equal to 20, I'm saying found equal to 0. As long as found is 0, continue the loop. So if found changes to 1, the loop will terminate. Now in the loop, I need to add one more thing. So I need bracket, and then if statement is one statement in the loop, another statement is test plus plus. The test has to go up and then close the loop. Okay, so here's how it works. Test number starts at 2. User enters 3 numbers. We got them in ABC. Test number started at 2. As long as test less than 20 and found is 0, I'll be testing the test number here. Testing testing to see if it divides all 3 numbers ABC. If it divides all of them, then I write that answer, and then I set the found to 1. I go on to increment the test number. With the new test number, I go up and check whether the test is less than 20, and also found has to be still 0. If the found is still 0, that means we haven't found the test number, so we need to proceed. So it will go on to test the new test number. And if the new test number is not a divisor, then test number goes up and loop continues. Anytime test number divides all 3 numbers, it'll write the answer, and it'll set the found to 1 so that the loop terminates. See, when the found changes from 0, loop will terminate. All right, when the loop terminates, there may be no divisor has been found. If a divisor has been found, then this cout statement would be writing that divisor. If it is possible that in the range 2 to 20, there is no divisor at all, then what will happen if there's no divisor? The test will go about 20 and it will become 21 and the loop terminates. Within the 20, there's no there's no divisor found. So loop goes all the way to test number becoming 21, and then the loop terminates. So down here after the loop, I need to check whether that happened. In other words, whether there was no divisor ever found. If that happens, I have to write appropriate conclusion. There are 2 ways to check that. One is test number should be 21 if there is no divisor found, or the found will still be 0. If the test number was, if a divisor was found, the found would have been changed to 1. So we can just look at that. We can look at the found or test number. I'm going to look at the found and say if found is still 0 when the loop ends, that means cout no common divisor. For those numbers, no common divisor was found. And I don't need an else, because only if found is 0, I need to write that. If found is not 0, I already wrote the common divisor here. This cout statement would have written the output. So yeah, you have to remember that no matter what happens, there must be a conclusion. So if there was a divisor found, this line would have written it. If there is no divisor found, then you have to write a conclusion, and that's why I wrote this. If found is 0, write this. That way the program is complete. It'll have some conclusion on the screen, and close the program. Okay, anything else?
In the review sheet, you did test equals 3, and then in the loop you did less than or equal to 19. Is there a reason for the difference? Like, is that also okay?
Okay, let me see why I did 3. Problem number 15. Smallest integer between 2 and 20. Okay, maybe I assume that between means not inclusive. That's what I think I did. Between means not including the endpoints. That's what I assumed. But that's if you just go from 2 to 20, that's acceptable.
Okay.
So I will be, if I don't want to include 2 and 20, I will be clear. I'll tell you clearly. Okay. So such matters are not considered to be wrong. Anything else?
Can we go over number 10?
Okay. Rewrite the program written in the last problem using the switch structure. Okay, this problem. Okay, let's see. Problem number 9 using switch structure. Let's clear the screen. Okay, so there is this income tax. You can only deduct 3,000 per person, and then interest paid for mortgage. All right, so let's begin with the main. We need to declare variables for all those. So float, gross will be gross income. And we'll have to calculate taxable income later, so call it taxable. And also mortgage interest, I'll call it interest. And then int number of members in the family, members. I'll come back to add more variables as I need. So we can ask the user to enter the information. I'm going to ask for all of them, but you can ask for one at a time. Enter gross income, the interest paid, and the number of members. Those are the information we need. So cin gross interest members. And after that, I'm ready to calculate my net income or taxable income. Taxable equal to gross. From gross income, you need to subtract 3,000 per person per number of per member in the family. So members times 3,000. And you deduct the interest also, interest paid for mortgage. So that's the taxable income. The next thing is to figure out the tax. To figure out the tax, I'll take that later. You need to use the switch statement. So if you're not using switch statement, you'll be using if-else if structure. If-else if structure, you know how to write. So I'm going to work with the switch statement. So if you look at the numbers, it's going 20,000 to 30,000, 30,000 to 40,000, so 10,000. That's what the length of the interval is. So 10,000 is an important number in making up your switch index. If you just divide by 10,000, that will work. Or subtract 10,000 and divide by 10,000. Those are possible formulas that can be working. So let's see what happens if I just divide by 10,000. If it is 20,000, let's start at the 40,000. If it is 40,000 or over, then it'll be 4 or larger. If it is between 30,000 and 40,000, then the number divided by 10,000 will be 3, right? Because if it is about 30,000, when you divide by 10,000 and take integer part, it's going to be 3, because if it is 32, let's say 36,000. 36,000 divided by 10,000 is 3.6. Integer part is 3. So for all those numbers, it will be 3. If it is in the 20,000 to 30,000 range, it will be 2. And if it is less than 20,000, it will be 1 or 0. So therefore, I can divide by 10,000. So my integer list, I have to go back and add index to use as switch index, and index equal to taxable divided by 10,000. And index is already integer variable, so it'll be taking integer part of it, and then switch based on the index. And if it is 0 is the lowest it can get. So therefore, hold on 1 second. Case 0 and case 1, in both cases, it'll be under 20,000. So I can just write one statement in both cases. That'll be 5% of taxable income. So tax equal to 0.05% of taxable income. I have to go back and add to the float list tax. That should be all the variables we need. Okay, so in these two cases, it'll be 5%, and then you have to break out. And then case 2 will happen if it is in the range 20,000 to 30,000, and then tax will be 8%. And break in that case. And then case 3, 30,000 to 40,000, that'll be tax equal to 10%. And then case 4 will happen if it is over 40,000. Now, case 4, now if it is 40,000 or over, it could be even 50,000 or 60,000, 70,000, 100,000. There are so many numbers over that. So that's why I decided not to start at 40,000. I started at 20,000. And now I can cover all the other possibilities in the default because there are too many. So default is the best way. Default, that means if the case is 4 or larger, any number, then the tax is 13%. You have to break here. And that'll be it. So after that, you see out the tax. So I divide by 10,000. Almost all the time, it works when you divide by the length of the interval. Almost all the time. Sometimes it's, you have to subtract 10,000, then divide by 10,000. That'll work better sometimes. So you can just use this as a formula and try it first. The number divided by the length of the interval. All right, anything else? Okay, we are at 10:39 now, so we are out of time anyway. If there's a quick question, I can answer it. Otherwise, we're all set. All right, so I strongly advise you to go over all of the homework problems and make sure you know how to do them. The test will not have a problem that's same as homework problem, but very much like them. The ideas and techniques that you learned in the homework is what I'll be testing. In the homework, I have covered all the different techniques and ideas that you need to know. And it's the same thing I'm checking using different questions. So if you go over the homework problems and also the projects, and make sure you know the ideas and techniques involved, then you'll be fine. As an additional practice, go over this cumulative review to make sure you understand it. I mean, you must have done that already, and you asked all your questions here. You have one more chance to ask the questions on these on the review or homework again in my office hour, which is going to be on Sunday. That'll be your last chance to ask questions before the test. All right, good luck in the test. Enjoy the rest of the day. I'll see you in the test. Like I said, you can begin at 7:30 if you like. And if students from this class start at 7:30, they'll need the password. So you're gonna have to ask me for the password. All right, have a nice day. I'll see you Monday. Have a nice weekend too.
Thank you, you too.
Thank you.
Bye-bye.
Hello, Professor. So I just have one question. Like after this exam, is it straight towards a final exam?
Probably because it's kind of tied to have a third exam. But if the time permits, I will give third exam. Otherwise, we'll have to go right into the final.
Got it. And like one more thing, if I have any questions, is it fine if I could schedule a Zoom meeting before the Sunday?
You can request it. I'm going to be busy tomorrow and Friday. I may be able to set one up. I'll be away for the next 2 days, but I may be able to still do it or using my laptop. So yeah, if you need one, just request it. And if you request it, then you had to keep checking your email because I may set one up. And so you had to keep checking email to see when the meeting is. Okay.
Got it. But that's fine with you, right?
Yeah, it's fine.
Okay, got it.
It may be instead of Thursday or Friday, it may be Saturday, but I will set one up for you.
Got it. Thank you, Professor. Have a good one.
You're welcome. You too. Bye now.